This is a finished solar panel's wiring diagram. In the next few minutes, every single line on it will make sense. This is how to wire solar panels, the beginner-safe way. Panels on the left, a charge controller, a battery, an inverter, loads on the right. Follow the power from left to right, and the whole system reads like a sentence. Let's take it apart piece by piece. Every off-grid solar system is the same 5 parts in the same order. Master that order, and every diagram you ever open suddenly makes sense. Start with the solar panels. They turn sunlight into DC electricity, direct current, like a battery. That power flows into a charge controller. Think of it as the brain of the system. It regulates the panels and stops the battery from overcharging. There are 2 kinds, PWM, which is cheap and simple, and MPPT, which is smarter and squeezes more power out of your panels. Next, the battery. It stores energy for the night and for cloudy days. Then an inverter, which turns the battery's DC into the AC your appliances actually run on. And finally, your loads, lights, a fridge, a laptop. Between every stage sits a fuse or a breaker. And the whole system shares one common ground. Panels, controller, battery, inverter, loads. Quick note before we go deeper. The editor on screen is completely free. It runs in your browser, and it is the first link in the description. Open the exact solar diagram there and follow along. No install, no sign up. Right, let's talk about the part everyone gets stuck on. Series versus parallel. This one choice sets your system's voltage and its current, so it is worth slowing right down for. Start with series. You wire panels in series by connecting the positive terminal of one panel to the negative of the next, like links in a chain. When you do that, the voltages add together. 2 12-volt panels in series give you 24 volts. 3 give you 36. But here is the key. The current stays exactly the same as a single panel. Higher voltage, same amps. Why does that matter? Because MPPT charge controllers love a higher input voltage. That is where they do their best work. And higher voltage travels better over long cable runs. Less current means thinner wire, and less power lost is heat along the way. So series is the choice for MPPT setups and long distances. Now flip around, parallel. This time, you tie all the positive terminals together and all the negatives together. The voltage stays the same as one panel, still 12 volts. But now it is the current that adds up. 2 panels double your amps. 3 triple them. Same voltage, more current. The mirror image of series. Parallel has one big advantage, shade tolerance. Because each panel feeds in on its own, if one gets shaded or covered, the others just keep working. Series strings are far fussier about shade. Parallel also pairs nicely with a simpler, cheaper PWM controller. The trade-off? More current needs thicker, more expensive cable. And you want a fuse on every single panel, because a fault in one can be backfed by all the others. So, series or parallel. Here is the short version. Series, higher voltage, same current, for MPPT controllers and long runs. Parallel, same voltage, higher current, for PWM controllers and shady spots. And plenty of real systems do both. You wire small groups of panels in series, then connect those strings in parallel, the best of both worlds. But whichever you choose, one rule is non-negotiable. The panel voltage has to match what your charge controller can actually accept. Push too many panels in series, and the string voltage can climb past the controller's limit and destroy it. So before you wire a single connector, read the maximum input voltage printed on your controller, and stay well under it. Let's build the chain in the free editor, so you can watch it come together. I will drop a solar panel on the left, that is our source. Then a breaker to guard the line coming out of it. An inverter in the middle, turning DC into AC. A light fixture on the right, standing in for a load. And a ground along the bottom rail. Every symbol snaps straight onto the grid, evenly spaced, so nothing lands crooked. Notice the layout. Source hard on the left, load over on the right. It is the exact same left to right story we started with. Now the 3 things beginners skip and really shouldn't. First, fuses and breakers. Every wire has a current limit. A fuse is simply the part designed to blow before that wire ever gets hot enough to start a fire. Put one right at the battery's positive terminal. That battery can dump enormous current into a short. And put one on each panel string. Second, wire gauge. Thicker wire carries more current safely. Undersized wire runs hot, drops voltage, and quietly wastes the solar you paid for. Size it to your amps and the length of the run. Longer runs need thicker wire. Third, the ground. Every metal panel frame and the system's negative side ties to one common ground. So a fault has a safe path to take instead of finding you. Back in the editor, we wire it up, right angles only. From the panel's positive terminal, straight across to the breaker. Out of the breaker, into the inverter. From the inverter, out to the light. Then the return path runs along the bottom, back to ground, closing the loop. Watch each wire turn at a clean corner, all by itself. Because the parts were placed on the grid first, the finished diagram simply reads: source through the breaker, into the inverter, out to the load, and home again. One honest word on safety. DC solar can be genuinely dangerous. A long series string can sit at over 100 volts in bright sun, and there is no switch to shut it off the way an AC breaker would. So treat it with respect. This video explains the diagram, so you understand how your system fits together. For a real installation, size everything to your local code and have a qualified installer check it. Here is the finished diagram once more: panels, controller, battery, inverter, and load, every part now making sense. So that is how to wire solar panels without the mystery. 5 parts, in order: panels, charge controller, battery, inverter, loads. Series adds voltage. Parallel adds current. Fuse every stage. Size your wire to the current and ground the whole system. The editor is free at circuitdiagrammaker.app. Open the solar diagram, rewire it in series or in parallel, and watch the layout follow along. If this finally made solar wiring click for you, subscribe. More wiring tutorials are on the way. Thanks for watching, and stay safe out there.